This video carries on from the Making Sense of Organic Mechanisms Part 1 video. It's best if you've watched that before watching this one. Like the first video, it seeks to build a general confidence in how to use mechanism arrows rather than just going through the particular details of one of the mechanisms that you need to know for the A-level course. Like the first video, it looks at the use of hole-headed arrows, showing the movement of a pair of electrons, and this time we'll get you to predict the structure of a product if you're shown the reactant and the arrows. Rather than just talking in some abstract way about how to predict the structure of a product if shown mechanism arrows, I'm going to look at a whole range of examples, lots and lots of them. Initially, I'll go through it in some detail, and then as you grow in confidence, you can have a go at predicting the product structure and then just checking the shown answer. It's always a good idea to put on partial charges where these are present and in some way relevant to the attack that's occurring. So I'll always encourage you to do that. In this case, we've got the polar C-Br bond as shown. I'm going to go through why that happens. That's from a different part of the course and something that you might want to revise if you're not sure about it. So what have we got going on here? Well, we've got one arrow taking a pair of electrons into the space between the oxygen and a carbon. So we can expect a bond to be forming there. Covalent bond is a shared pair of electrons. So where we've got a pair of electrons going into a space between two atoms, we can expect a bond to form there. And we've also got an arrow heading away from a bond. And so that'll be taking the shared pair out of that bond, and that bond will cease to exist. So for the product, we can expect a new bond to form between the oxygen and the carbon, and the existing bond between the carbon and the bromine to break. Let's have a look at that product. And just notice that as well as the expected bond forming to have happened, just change the angle there, but it's a bond between the final carbon on the right and the oxygen of the hydroxide ion. And we've also lost the bond to the bromine. We also have to think about charge, and this always is something that you should mentally check when it comes to mechanisms. If you watch the part 1 video, remember where you've got an arrow moving away from an atom, that's carrying negative charge away from it. So the hydroxide ion had the oxygen with a negative charge on it. The arrow came away from that, and so we can expect to have gone up from the 1- to a neutral charge, and you can see on the oxygen in the product now we have no ionic charge present. Don't confuse that with the polar bonds, the partial charges delta plus, delta minus. Those will be present because of unequal sharing of electrons, but we're just thinking about ionic charge in response to these mechanism arrows. For the carbon that's kind of involved in this process, we've got one arrow heading towards it, bringing negative charge towards it, and one arrow heading away from it, taking negative charge electrons away from it. And so overall there's no effect on its ionic charge. It didn't have an ionic charge to start with, and it still doesn't at the end. The bromine, however, has an arrow heading towards it. It didn't have any charge in terms of ionic charge to start with, and so with negative charge being taken towards it, we're going to go down from 0 charge to -1. And so we see for the product, not only has the bromine broken off, is no longer bonded to the carbon, but it now has a negative charge on it. So the next 3 slides are all going to be steps in a mechanism that you don't need to know, an elimination reaction, the dehydration of an alcohol using hydrogen bromide as a catalyst. But the point you don't need to know it is almost of special value here, because this is all about being able to flexibly predict structures that aren't in a familiar context, which is something that the exam will make you do rather than just relying on memorized recall. As ever, let's make sure we've got the partial charges shown. So those are the kind of ones relevant to the bits of the molecules involved. And then looking at the mechanism arrows, we have a bond forming arrow taking a pair of electrons into the space between the oxygen and the hydrogen here. And we also have a bond breaking arrow heading away from a bond, taking the electrons out of it and onto the bromine atom. So let's look at the product that we get from that. And hopefully it's not a surprise. You can see the new bond formed here where the arrow took a pair of electrons between the oxygen and the hydrogen to form a bond. And we also have the bromine now as a bromide ion, where the bond that it had to the hydrogen has broken. So the arrow took the pair of electrons out of that bond. Again, we must always stop and think, what about charge? And it's going to be an important point of a part of predicting the structures is to put the charges on correctly. And so what's involved here? Well, we've got the oxygen, which didn't have an ionic charge. It's got an arrow heading away from it, taking negative charge away. So that's going to take it from neutral up to a +1 charge, and so we see the positive charge on it there. The hydrogen that's involved in the process, well, it didn't have an ionic charge. It's got an arrow heading towards it and an arrow heading away from it. Those are going to cancel out, so no ionic charge on that. It started neutral, it's stayed neutral. The bromine, on the other hand, didn't have an ionic charge. It was neutral, but it's got an arrow heading towards it, taking negative charge to it. So it's going to go down from having no 0 charge to a -1 charge, and we've got the bromide ion there as a result. So this is the next step in the mechanism that was started on the previous slide. This time there aren't really any partial charges of relevance here. There are some polar bonds, but they're not of significance to what's going on here. We've got an unstable structure with this positive charge on the oxygen that is going to rearrange in some way. Just one arrow this time, and it's an arrow breaking a bond, coming out of a bond, taking the pair of electrons. So we can expect this bond to be broken, and those electrons are going onto that oxygen. The product, well, is this what you were expecting? We have indeed broken that bond, and again, charge has done some interesting things here that we need to be able to predict. So let's just unpack that. The carbon involved in the process started out without an ionic charge. The arrow went away from it, carrying negative charge away. So its charge went up from 0 to +1. The oxygen, the only other atom that's really involved here, started out with a +1 charge, and the arrow came towards it, bringing negative charge towards it. So that went down from +1 to 0. So the oxygen in the water as a product now has no ionic charge on it. So in this final step of this elimination mechanism, we now have the bromide ion involved that was formed in the first step, but really don't need to worry about where it came from. We just need to react to the arrows shown here. So this is the last one I'll describe in detail, and then there'll be a whole series of ones for you just to have a go at. So 2 arrows this time. We have a bond forming arrow taking a pair of electrons into the space between a couple of atoms, so we can expect a bond to form there between the hydrogen and the bromine. And we have a bond breaking arrow taking the electrons out of the space between the carbon and the hydrogen. But interestingly, this time, rather than going onto an atom and changing its charge, perhaps the pair of electrons is heading into the space between 2 other atoms. So this is a kind of a transfer of a bond from one location, taking the pair of electrons where it was between the carbon and the hydrogen, to another location between 2 atoms, this time between the 2 carbons. So we can expect a new bond to form between the bromine and the hydrogen, the existing bond between the hydrogen and the carbon to break, but now a double bond to be present between the 2 carbons. So let's have a look there, and that's what we've got. We still have the hydrogen and the CH3 group attached to the carbon that were already attached, but the top hydrogen here has gone and is now bonded to the bromine, and indeed we do have this double bond between the 2 carbons. Charge-wise, let's just explain that to make sure we're getting the idea. We've got the bromine involved, started off with a -1 charge, arrow heading away from it, taking electrons, hence negative charge away. So it's going to go up from its -1 charge to 0 in the product. It's now neutral, not got an ionic charge. The hydrogen involved, well, it's got an arrow coming in and an arrow going out. They cancel out. So where it started off without an ionic charge, it still doesn't have an ionic charge in the product. We do also have these two carbons involved. The carbon on the left here, well, although we might think an arrow is kind of heading away from the bond that it was involved in, it ends up in another bond that it's involved in. So this is in effect an arrow going away and towards where this carbon is involved. So no change to its charge. It didn't have an ionic charge in the reactants, and it still doesn't have an ionic charge in the products. But the other carbon here, the one that started out with a +1 charge, we have an arrow heading now in towards it effectively. And so that's negative charge moving on to it, and so we go down from the +1 charge to 0 to a neutral charge, and so in the product it now no longer has that positive charge. It doesn't have an ionic charge on it. So as promised, now some examples for you to have a go at making the prediction. The first couple of slides are for a reaction that you really shouldn't recognise at all, but so much the better. Your job really is just to look at the arrows and to make a decision about the bonds breaking, bonds forming, and also don't forget charges changing as well. And don't forget to pop on some partial charges where you think those might be relevant for the groups involved in the reaction. So why don't you pause the video here and see what you can predict for the product structure. Relevant partial charges would be on the C double bond O group there, and the product should look like this. You might not get the bond angles exactly the same, that really doesn't matter. But just to highlight the key features, the negative charge on the oxygen in the reactant should be gone in the product. We should now have a bond from that oxygen to the central carbon of the reactant, new bond there. And where there was the double bond to the oxygen in the reactant, that is now a single bond, and there's a negative charge on that oxygen where it wasn't charged in the reactant. So here's your next little challenge. It carries on from the step in the previous slide, but that really doesn't matter. For a bit of fun, 3 arrows to look at here. Don't let that intimidate you. Just make your decisions for each arrow about bond breaking, bond forming, and think about charge as well. So why don't you pause the video, see if you can sketch out a predicted product structure for you to check in a moment. And the products should look like this. Again, don't worry about bond angles. That's not important here. It's what's attached to what and the charges that count. Just to highlight the key features, we've got this R1O group broken off now and a negative charge on that oxygen. The C single bond O has changed to a C double bond O, and we've lost the negative charge on the oxygen. The oxygen is not charged anymore. And rather interestingly, this R2 group has kind of changed its loyalties. Where it was bonded to that central carbon, which is this one in the product, it's now got a bond to the oxygen instead. All the remaining slides are in fact steps in one long mechanism, and it's a reaction that you might recognise. It's going to be the reaction between a carboxylic acid and an alcohol to form an ester in the presence of an acid catalyst. So it's something that in an exam you should be able to say, how do you form an ester? You can heat a carboxylic acid and an alcohol under reflux with an acid catalyst, often concentrated sulfuric acid. In this case, it's going to be hydrochloric acid shown. It's a mechanism that you're not supposed to actually know, so perfect training ground in a way for just looking at the arrows and deciding the effect. So in each case you're going to see the reactants with the arrows shown. You can pause the video, see if you can figure out what you think the product structure will look like just from the arrows. Remember to think about charges moving around, bonds breaking, bonds forming, and also it's a good idea to sketch any relevant partial charges onto the reactant. So I'm not going to say much here. I'll just bring up the reactant. You can pause the video, decide on the product, check the answer shown. If you don't get what I've put down, don't worry if it's just about bond angles. That's really not going to be relevant to you getting these questions right. It's all about the bonds breaking and bonds forming and the charges. But if you're getting that side of things wrong, then take a bit of time to ponder, look at the correct answer, look back at the arrows, and see if you can figure out why the answer is correct. But obviously, if this thing's confusing you, you might want to go back earlier in the video and watch again at some of the more detailed explanations. So here we go. First one, pause the video and see if you can work it out. So some partial charges and a product structure as shown. Next step. And the answer with some partial charges there. And the next step. And the answer. Partial charge is not really relevant to what's going on here. And the next step. Some partial charges and the product structures. And the next step. And the product structure. No real relevant partial charges there. And the next step. And the product structures. And that's actually the end of that mechanism and the end of this video. We've formed our ester and the hydrochloric acid is back.